You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light-years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light-years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes 1 revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.